Greetings and welcome to the Introduction to Astronomy. In this week's Misconception in Astronomy, we are going to talk about our planets and find out if they are really perfect spheres. So, are planets spheres? Well, the answer is no. Now, if you take a look at Earth there, Earth looks very spherical. But if you actually measure it carefully, you'll find out that it is not quite spherical, and it is in fact a little bit larger in the equatorial diameter than it is in the polar diameter. Now, they are roughly spherical, and that's due to gravity. Gravity will pull any massive object, any object that has enough mass in it, will crush out any irregularities and make it into a sphere. Now, ideally, it would be very close to a sphere, but there are various reasons for the differences. One would be the surface features. Certainly, any planets that have a solid surface, we know they have mountains, they have valleys, and they are not going to be perfectly spherical. However, this is a relatively small amount, and in fact, if we want to figure this out for Mount Everest here on Earth, it is less than 0.1% of a deviation from a perfect sphere. So Earth really, if you account the surface features like that, is really close to being a perfect sphere, just based on this. However, there are other things that are occurring, and the primary one that causes things to be distorted is the rotation of Earth. As an object rotates, the forces will push it outward at the equator and cause objects to bulge and make it what is called an oblate spheroid. So essentially it is a squashed sphere, and we can see a sphere to the left there and the oblate spheroid down over to the right. And it's just kind of squashed in at the poles. Now, this is a very extreme case. In Earth, it is a very, very small difference. And in fact, we can take a look at that here. And for Earth, the equatorial diameter is 12,756 kilometers. The polar diameter is 12,714 kilometers. Almost a perfect sphere. Were it a perfect sphere, those would be exactly the same. But it bulges more at the equator and is squashed down at the poles. For Earth, that is a 42-kilometer difference, or about 0.3%. Earth is pretty solid. It doesn't deform as easily as something that would not be solid. So we want to look at, say, one of the gaseous planets. And in fact, if we take a look at this same thing for Saturn, we find that Saturn has a difference between its equatorial and polar diameter of 11,808 kilometers, or nearly 10%. So while you would not be able to see Earth as being a squashed sphere, you could actually notice that Saturn is not quite right, that it's a little bit more squashed when we look at it in the polar direction than we do in the equatorial direction. And that's because it's nearly there, if we take a look, nearly a 10% difference between the two. Now, as you might expect, the other giant planets that spin rapidly, they have a gaseous and liquid composition, and they're spinning much faster than Earth, and therefore are going to be more distorted from a perfect sphere. The other planets like Earth, there will be a little bit closer. It'll be a smaller percentage. They're solid, they're harder to distort, and in general, they're not rotating near as rapidly as the larger planets. So let's go ahead and finish up here with our summary. And what we talked about is that the planets are approximately spherical, but are not perfect spheres. They are what is called an oblate spheroid, and the amount of the deviation from being a perfect sphere depends on two things: the rotation and the composition of that planet. So that concludes this week's Misconception in Astronomy on the planets being perfect spheres. We'll be back again next week for another Misconception in Astronomy. So until then, have a great day, everyone, and I will see you in class.